This is an introduction to partial differential equations. This is sort of aimed at first year, second year college students. So given this expression here z equals e to the 2t sine of 4x, what we have here is an expression, a function, where z is a function of two variables t and x. Okay, so it's a function of two variables, and in general what we're talking about here is functions of several variables. So what we have to do is prove this identity here. This is our little differential equation, as we call it, partial differential equation. Second derivative of z with respect to x plus 4 times the second derivative of z with respect to t is equal to 0. This is something we have to prove. Now what I'm going to do here is actually, before I go any further, is I have a few notes. I have this a bit of this prepped already. Derivative of e to the ax is a times e to the ax. Derivative of sine ax is a cos ax. And derivative of cos ax equals a minus a times sine ax. Now this is using the chain rule in each case, and just very basic trigonometric cos and sine, derivatives of each other. And all we're doing also is, this is just using the chain rule. Okay, I take the view that these identities could be known automatically without having to prove them. Okay, so that you can just automatically say derivative of this is this. Let's do a quick example there. Second, the derivative of e to the 2x is necessarily 2 times e to the 2x. Okay, so I'm going to sort of come back down here a few times during the course of the presentation, just to sort of remind ourselves what to do here. But it would be handy if you sort of had this sort of ready in your mind already. These are the building blocks of what you are going to be doing here. So first off, what we're going to do is get the derivative with respect to x. So we're going to work here with respect to x in this time round. Okay, so here is our expression there again. Z equals e to the 2t sine of 4x. That's what we're going to be working with. Now the thing about this is that oops, I covered the z there. What we're dealing with here is a expression in terms, or we're differentiating with respect to x, as we can see here. This is a constant as far as x is concerned, so we're just going to treat this as a constant for this entire phase of the exercise. So e to the 2t, just treat it like a constant, bring it straight down. Okay, now sine of 4x, what we have to do is differentiate this bit here. Okay, so let's just go back to our sine of 4x. What do we do there again? Sine of 4x is a cos ax, so 4 times cos of 4x. Okay, so 4 times cos of 4x. Okay, so let's just tidy that up. What we could do there is just rearrange it, just make it a little bit neater to look at. Have it 4 times e to the 2t. Okay, what we have to do now is get the second derivative of z with respect to x, second partial derivative. So what we have to do that is differentiate that again, or differentiate this term here with respect to x again. And just like we've done the last time, as far as x is concerned, this is all a constant, so we're just going to bring this all down. So this is 4 times e to the 2t. Okay, cos of 4x, just going back to our little cheat sheet there, cos of 4x is minus a times sine of ax, or minus 4 times sine of 4x. So let's just bring that there, minus 4 times sine of 4x. Okay, and again we can tidy that up. We have an expression here with 4 times minus 4. So what we could do is actually just rewrite this expression, simplify it, and have it as minus 16 times e to the 2t sine of 4x. So this is the first part of the equation that we have to solve. Let's just go back up to it there. Cos squared, second derivative of z with respect to x. We have that job done. Now we have to do something similar for this side over here, the other side, the right hand side. So let's just go down to where I have that sort of ready. So this time we're going to work with respect to t. Now, as far as t is concerned, we're going to treat this as a constant. Okay, sine of 4x is just going to be brought down at each stage. So e to the 2t, what do we do there? A times e to the ax. So here we have 2t, where I'm working in terms of x. This is in terms of x, I'm working in terms of t. But essentially just second derivative of e to the ax is just a times e to the ax. Okay. So derivative of z with respect to t, the partial derivative of z with respect to t, is 2 times e to the 2t and sine of 4x. Get the derivative of that again. So just to be clear, this is a constant. Let's use green there. This is a constant and this is a constant. So we're just going to bring them straight down before we start the differentiation. Oh, my pen is slightly thicker. And what do we have to do? We have to differentiate this part here. So that is 2 times e to the 2t, again, just exactly like the last time. So we can tighten that up. That's 4 times e to the 2t sine of 4x. Okay, now let's just go back to the original equation, what we have to deal with, because I don't think it was the second derivative on its own. What was it? It was 4 times the second derivative with respect to t. So let's put that in there as well while we're working on it. So 4 times d squared z, the second derivative of z with respect to t equals simply 16 e to the 2t sine of 4x. Okay, so you might notice that that expression and that expression are equal to each other except but opposite in magnitude. Okay, so let's just write them both out together. So go right down to the end and let's put a new page there. So first thing we do, so what was that? Or let's just split the page up in two. That wasn't very good. Let's do that again. Let's just go back up here. So the first one was the second derivative with respect to of z with respect to x is minus 16 e to the 2t sine 4x. And let's go back to where I'm writing this down. So this is x here. And again, what we're saying, that is minus 16 e to the 2t sine of 4x. You can just check your notes there. Essentially, also what we're saying is plus 4 times dz's second derivative of z with respect to t. That is equal to plus 16 e to the 2t sine of 4x. Okay. Let's just go back up there. There we have it there. Double checked. Good stuff. Okay. So add them up. This is the equation we're looking for. And add this and this together. You pretty much see that they almost immediately cancel out and you're left with 0. So we have that done. It's the way I have it there is just to sort of to suit the screen size. It doesn't try and make it a bit neater when you do it in pen and paper. And I'm just going for legibility on the screen on YouTube, but try and go for a different way of presenting it when you're doing it on pen and paper. So that is the first of our introduction to partial differential equations. I've got a few more on the way.